Hey everybody, this is Mr. Bells here. This is a video on equations of circles and what those look like in terms of the coordinate plane. Worksheet that goes with it, kind of going through the solutions to this. So, looks like this, day 5, equations of circles. I'm just going to start in the beginning. Anytime that you have an x squared plus a y squared, and it equals some positive number, and again it's got to be a positive number, that's going to be the shape of a circle. Since there's no shift on the x and no shift on the y, that means the center right there, the center is going to be at 0, 0, because there's nothing pushing the x or the y. You can see some of these ones down here a little lower, where there's an x plus 2 and a y minus 5, or an x plus 5, y minus 3. It's those types of things that actually shift the circle. And then this number right over here is equal to the radius squared. So in order to be able to find the radius, I simply square root that number. So in this case, the radius would be 3. So if I was to graph this thing, I'd go 3 to the right and put a dot, and 3 up and put a dot, and 3 to the left, put a dot, and 3 down, put a dot, and kind of make this curvature thing just like that. So there's this circle, x squared plus y squared equals 9. Look at these ones down here. The general formula, it looks like this, where there's an h and a k, and that h comma k is telling you where the center of that circle is, and this is showing you it's the opposite of whatever the number is, and the opposite of whatever the number is that actually gets you for shifting that circle someplace off the center of it. So for instance, if I had something that was a circle, looks like I don't have a quarter or anything with me, but we use a little district volleyball medal. So if it was centered at the origin, it'd be here. We can move it off, up to the right, left, down, any place around here. And we move that or shift that basically by moving things here. Okay, so this one right here, center of this equation right here is going to be at 3, 1. So again, the opposite of x minus 3, or the opposite of minus 3 is going to be 3, and the opposite of minus 1 is going to be a 1, and the radius is 5. And again, what that means is I would go to 3, 1, 1, 2, 3, and up 1. That would be the center of my circle, and then from there, I'd go 5 to the right, and 5 up, and 5 to the left, and 5 down, and that would be that circle. Looks just like that. And you could plug any of this stuff into Desmos, and it would show you exactly what I'm talking about. If I go here, the center of this one, you can see that there's no shift at all on the x, so that'd be a 0. There is a shift on the y, that would be a minus 8, and then the radius equals 2 in this case. Moving down here, center at negative 2, 5, and the radius is 7. This one, center is 7, 10, and the radius is equal to the square root of 20, which you could leave just like that, or you could go ahead and plug it into your calculator and get what that square root is. You know, we're looking at probably about 4.5, something like that. Let me pull it up here on this calculator just so you can see it. Reminder again, we just simply have to enter it in here. Second square root 20. Looks like I got a dash on there. Let me delete that. And 4.47. So my approximation of 4.5 without the calculator, pretty good in that case. Okay. So ours approximately 4.47. Doing this one down here. So you should guess. So what do you think the center is? Awesome. On this one, I'm going to try and write it down before I do it. Sweet. So did you get this? Center is negative 5, positive 3, and a radius equals 4. This one over here, center is equal to negative 2, 0. Again, there's no shift on the y, and the radius equals the square root of 8, or some number a little bit less than 2, approximately. Again, you can pop this on here. and do the square root of 8, enter, and you get 2.83. I'm comfortable with that. Okay, so that's what the equations of those circles look like, and hopefully you could graph it from there. If you flip this thing over, now what we're asking for is, hey, now that you have this picture, could you write an equation out for this? So first thing we'd have to do is we'd have to count how far wide it is. So if I did this, it looks like it's 3 and 9, so it's 12, 3 to the right of the y-axis and 9 to the left of the y-axis, so it's 12 completely wide. And so if I draw this straight up and down and this straight across, you can see that that's my center right there. So I go over 1, 2, 3, negative 3, and up 3. So my center is at negative 3 comma 3. And if that's the case, then my equation is x plus 3 quantity squared. And without the squaring, it'd be a straight line, so I got to make sure the square's there. Plus y minus 3 quantity squared equals, and then I count boxes. 1, 2, 3, 4, 5, 6. So the radius equals 6. So then that should give you 36, and that's what that one looks like. If I come over here to this one, same thing again. I'm going to go ahead and put my crosshairs in. Looks like the center of the circle is right there. So I write it over here. Center is 4 comma negative 2. Radius is equal to 4. So my equation for this picture is x minus 4 quantity squared plus y plus 2 quantity squared equals 16. That's what that one looks like. So these ones down here, hopefully you have, again, please stop the video at any time, try it on your own, make sure that you're doing it and you're not just copying the stuff that I write, but you actually understand why it works the way it does. So I'm going to go ahead and do this here, and I'm going to get this line going across here and this line going across here, and I should get a center right there of negative 4, negative 3. So if my center is negative 4, negative 3, then I should have x plus 4 quantity squared plus y plus 3 quantity squared equals, and then count 1, 2, 3, 4, 5 boxes, should equal 25. And again, on any of these ones, if I was to actually graph them, it should look like this. So I don't know how this is going to work, but I'm going to give this a shot right now. I'm going to turn this up here like this, down, and have you look at the video, and hopefully it will come out wonderful for you. So we're going to go here, we're going to go here, and Desmos, and I'm going to put in that last one, so shift parentheses, a better view of that, parentheses, x plus 4, parentheses, down here, use the little keypad, squared, plus, parentheses, y plus 3, y plus 3, parentheses, squared, equals, and this was 25. And you can see that on Desmos it will give you a circle in the exact same place that we just saw on that paper. Again, you can kind of see it here, you can see it there, they are identical. Awesome. So I'm going to do this here, this back this. I know, professional videographer going on right now, right? Again, stop the video, try this one on your own. Jeopardy theme music, here we go. So this one goes like this and like this. Looks like the center is at 2, 2. So I'm going to have x minus 2 quantity squared plus y minus 2 quantity squared equals, and if the radius is 2, and that number is going to be 4. Down here it says find the equation of the circle with a given center and point. Well, I'm going to kind of say this. If it's got a center at 4, -1, 1, 2, 3, 4, and -1, and then it's got a point of -1, 2, so -1, 2. If that's the center and that's the point, then the circle is going to kind of go like that around it. So we need to be able to find that distance, and that distance will be the radius, and that will help us with it. So here we go. Here's our math. X minus 4 quantity squared plus y plus 1 quantity squared equals. Now to do the distance formula between these 2 points, I'm going to find the distance between the x's. So 4 to -1 is 5. I need to square that. And -1 to 2 is 3. I'm going to square that. So 5 squared is 25. 3 squared is 9. 25 plus 9 is 34. Remember, if I square root that, I would actually get the radius, but we want the radius squared as part of the problem. Remember, again, it equals radius squared. So let's go ahead and do this next one. Center is at 10, 0. So that means I have parentheses x minus 10 quantity squared plus y squared. No shift on the y because there's nothing that's moving left or right. And then equals. Well, the distance between 10 and 5 is 5, so that's 25 when I square it. The distance between 0 and 2 is 2. 2 squared is 4. 25 plus 4 is 29. And that's what's going to be on the outside of it. Again, the radius is not 29. The square root of 29 is the radius. The radius for this one would be about 5 point something. Here we go. This one. X minus 2 quantity squared plus y minus 3 quantity squared equals 2 to -4 is 6, so that's 36 when I square it. 3 to -1 is 4, 4 squared is 16, 36 and 16 is 52, and that's what that number would be. And you can check any of these. You can plug them into Desmos, plug that equation in, and then plot the point 2, 3, and -4, -1, and you can see that that point will be on that circle that is centered at 2, 3. Down here, center -3, 8, 0.7, -2, so x plus 3 quantity squared plus y minus 8 quantity squared equals, the distance from -3 to 7 is 10, 10 squared is 100. The distance from 8 to -2 is 10, 10 squared is 100. 100 plus 100 is 200. Again, the square root of 200 will tell you what the radius is. And again, the square root of 200 is something, it's probably right around 14.1. So if I was to do that and did 200 raised to the half power, knowing that 0.5 power, right there, 0.5 power is the same as a square root, hit enter, you get that. Square root 200, you see that those are both the same numbers. Okay. The last thing on these equations for circles, following up this big unit on circles, is determining if the following points are on the circle. I really change this to on, inside, or outside. So any of those possibilities. So the first thing I'm going to do is I'm going to check 2, 0. So when I check 2, 0, I'm going to plug 2, the x value, into the equation. 2 plus 1 is 3, 3 squared is 9. And then 0 in, 0 minus 6 is -6, -6 squared is 36. So I got 9 plus 36, which is 45. So the number gives me 45. The equation says it equals 45. So that is definitely on the circle. That is part of the actual circle. Now, in terms of what that means, if this is circle A, and I had these 3 points right here, here's B, C, and D, then that point right there, 2, 0, would be a point that's on the circle because it's exactly the same distance, the square root of 45, away from that center. Okay? Now, this next point right here, -3, 4, plug it in. -3 plus 1 is -2. Square root is 4. Plug the 4 in. 4 minus 6 is -2. Square root is 4. 4 plus 4 equals 16. 16 is less than 45, so that means it's inside the circle. And then negative 7, 3. Negative 7 plus 1 is negative 6 squared is 36. 3 minus 6 is negative 3. Negative 3 squared is 9. 36 plus 9 does equal 45. And you can see that that would be on the circle again. I'm going to throw another random point on here. Let's call it D. And let's say that's 10, 12. So I plug that in. I get 11 squared is 121. And 12 minus 6 is 6 squared is 36. 121 and 36 is 157. And that is, of course, bigger than 45. So that would be outside the circle. And again, if any of this went too fast, that's fine. That's what's great about videos. Stop it, pause it, slow that sucker down, use it for whatever you need for this. So again, equations of circles given coordinate planes. That's the stuff you need to know. Hopefully this video is helpful for you and that you'll be able to remember it. We'll talk to you later. Bye.